Okay. Sarah just wrote the numbers to put them in order. Let's take a look at it. Okay. So what is the angle whose cosine is 0? Thinking about our unit circle, we remember that it's cosine theta sine theta. So our cosine is our x coordinate when we're on the unit circle. So where is my x coordinate 0? So if we think about our circle, okay, with the radius of 1, boy, that's off center, but it's just a sketch. So our radius is 1, okay? So our x value is 0 up here at pi over 2. So that's pi over 2, okay? Our cosine, our x value is 1/2 at pi over 3. So this is pi over 3. It is root 2 over 2 right there in the middle at pi over 4. And it is root 3 over 2 right there at the bottom at pi over 6. So if we're putting these in order from smallest to largest, the smallest is actually the one with the largest cosine. So notice that the cosines already looked like they were in order from smallest to largest, but the smallest cosine is actually the biggest angle. So the smallest angle is actually the biggest cosine. So cosine inverse of root 3 over 2 is the smallest. Cosine inverse of root 2 over 2 is next. Cosine inverse of 1/2 is second to largest. And cosine inverse of 0 is the largest. Okay, so they were in reverse order there. Okay, questions for me about that? Just kind of fun to play with this. It just lets you look at it a little bit closer and figure out what's going on there. So we're just building our understanding of what we're talking about when we're dealing with inverses. Inverse trig values find angles, and so we're talking about those angles there. Any questions for me on that? All right, let's get going. Okay, so because we're not going to be on the unit circle, we're not going to be able to just grab the x coordinate as our cosine and grab the y coordinate as our sine. So we've talked about this before, but we want to make sure before we get going that everybody's solid on how to represent the trig functions in terms of x, y, and r. So here we have our triangle drawn in first quadrant. If you use your SOHCAHTOA to remind you. Okay, so if relative to our angle theta, x is the adjacent side, y is the opposite side, and r is the hypotenuse. So we know sine is opposite over hypotenuse, or y over r. Cosine is adjacent over hypotenuse, or x over r. And tangent is opposite over adjacent, or y over x. Okay. Let's see, I'm going to call on one of you guys to help me with my reciprocal functions. So let's take a look. Omar, can you help me with the reciprocal functions? What is the reciprocal of sine? What's the reciprocal of sine?
Wouldn't it be sine inverse?
No. Now that's a super important. I want to clarify.
Cosecant.
It is cosecant. Thank you. But that is a common misconception, and I do want to talk about y for just a second. Okay, so Omar, go ahead and tell us what cosecant is in terms of x, y, and r, and then we'll talk about that.
Isn't it r over y?
It is. It's r over y. Okay, so put a pin in where we're at here, and let's talk for a second about what Omar said for just a second there. Okay, so if I write x to the negative first power, that means 1 over x. Okay, if I write x to the negative first power, that means 1 over x. And so there, that is the reciprocal of x. Okay, that is the flip of the fraction, because regular x would have been over a denominator of 1. And so when you flip it, it would look like 1 over x. Okay, that is the reason people often get confused about inverses. Remember I said when we're doing inverse trig functions, when we write sine inverse, we're using the same notation that you've seen in other situations to indicate exponents, and I'm going to say y over r. Okay, but we do not mean negative exponents here. We're using that same notation, but we do not mean negative exponents here. That is inverse notation. So it's the same notation in a different setting to mean something completely different. So when we read that, it is not a capital N-O-T, not sine to the negative first power. It is the angle whose sine is y over r, or sine inverse of y over r, okay? Super important that you guys remember that. And remember, I think I gave the example when we were first talking about this, that just like if I did absolute value of -3, you would know that that was absolute value notation and you would tell me it was just 3. But if we were in our if matrix unit and I asked for, let me undo that real quickly, asked for that, what would it be? Not the absolute value of A, that would be the determinant of matrix A, okay? So it's the same notation, the straight bars, it's the same notation, but one means absolute value and one means determinant because it's in a different situation. So anytime we see that -1 on a trig word, it does not mean an exponent, it means inverse, okay? So we don't want to confuse ourselves and think that it means reciprocal because it doesn't mean reciprocal, it means inverse, okay? When I ask for the reciprocal of cosine, I'm talking about the flip of the fraction. And Omar, what is the reciprocal of cosine?
Secant.
Yes. And it looks like?
R over x.
Beautiful. And when I ask for the reciprocal of tangent, I'm talking about?
Cotangent.
Mm-hmm. And it looks like?
X over y.
Beautiful. Okay. So it's a common mistake because it's the same notation, but it does not mean the same thing, and we want to make sure we understand that, okay? And when I taught this for 8th block yesterday, we had lots of good questions that showed students were really trying to put together their thinking. And so if you've got questions, I want you to ask them. We really want to make sure you understand the math that we're doing, okay? All right, so we've seen this little chart in our notes throughout this unit. The question when we're finding our inverses has been, first of all, is it on the unit circle? And so up until today, it's been on the unit circle. So we just focused on which quadrants we were in for that inverse function, and then where in that quadrant we saw that value on the unit circle and what angle that was there, and that was our answer because inverse finds angles, okay? Today we're going to be dealing with ones that are not on the unit circle. And so what do you do if it's not on this unit circle? Our first step will be to draw a triangle. And we'll still have to think about what quadrants our triangle would fall in, okay? And then we're going to think in terms of SOHCAHTOA, or our x, y, and r for our trig functions to figure out the answer that they're asking for. So let's get straight to it. Fun things ahead. Let's give it a try. Okay, so find the value that satisfies the given equation, simplify all fractions. That's the wording that you're going to see on the test and in the study guide, so I just went ahead and used it here in our notes so you'd understand. It just wants us to find the answer to that equation. Okay, so let's do it. It would like the tangent of the angle whose cosine is 5 over 7. Okay, it wants the tangent value of the angle whose cosine is 5 over 7. Tangent of cosine inverse of 5 over 7 is just looking for the tangent value of the angle whose cosine is 5 over 7. So the angle whose cosine is 5 over 7 is just some angle. And it turns out we don't actually have to find what the angle is to tell us what the tangent is. They want the tangent, they want the y over x value, and we can find it without ever actually finding the angle. So let's give it a try. All right. We're talking about cosine inverse of 5 over 7, the angle whose cosine is 5 over 7. That cosine is positive, so what quadrant should we draw our triangle in? If 5 over 7 is not a cosine value I have memorized from the unit circle, okay, it's not anywhere on the unit circle, so we're going to have to draw a triangle. So what quadrant should that triangle be in if cosine inverse is positive? Where will that take us?
Quadrant 1.
Yeah, quadrant 1, where everything's positive. So let's go ahead and do our Cartesian plane and draw a triangle with the radius coming out from the origin, drop in altitude perpendicular to the x-axis, and that's the x, y, and r triangle that we're going to use to find the trig values of this angle theta that we're talking about here. Okay, Now, all we know about this angle so far is that its cosine is 5/7. So cosine is what, David, in terms of x, y, and r? Cosine is what? In terms of
Cosine is the x value.
it's x over what?
Oh, x over radius.
Right. It's only just plain x if we're on the unit circle, and we've already established that we're not on the unit circle. Okay, so it's always x over r. It's just that when you're on the unit circle, the radius is 1, so that denominator is 1 and we don't write it. Okay, but we're not on the unit circle, so it's x over r. Notice I wrote that x over r right next to the cosine value there. Okay, that means my x value is 5 and my r value is 7. And if I know two sides of a right triangle, we can always find the third side with dun, 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 Pythagorean theorem, right? So let's do it. Let's use Pythagorean theorem to find that y value for our triangle, that third side of our triangle. So I've got 5 squared plus y squared equals 7 squared. Okay, so 25 plus y squared equals 49. I'm going to subtract 25 from both sides. Y squared equals 24. How do we undo a square? How do we undo a square? Anybody can answer. Square root. So when I take the square root of both sides, something super important happens. We pick up the plus or minus option, okay? So that gives me y equals, if I break down 24, that's 2 times 12, 2 times 6, 2 times 3. When the number on the right is prime, we're done. We're looking down the left side and across the bottom. I've got a pair of 2's. And I've got a 2 and a 3 still multiplied together under the radical. So that's going to be 2 root 6. Do we want the positive or negative option for our y value? Looking at our triangle, it's in quadrant 1 where everything is positive, So we're going to throw out the negative option. We want the positive option there. So y is 2 on the square root of 6. Okay, so y is 2 on the square root of 6. Okay, so we use the trig value they gave us and look at it in terms of x, y, and r. Plug those two values in and solve for the third value. Okay, questions for me about that? Okay, now that we have all 3 sides of that triangle, we can find any of the 6 trig functions they want. We can find any of the 6 trig functions they want. Okay, which one do they want? They would like the tangent of this angle whose cosine is 5/7. We never even had to find the angle, but we can definitely find its tangent. Tangent is just y over x. Our y value we just found out was 2 root 6. Our x value is 5. So tangent of the angle whose cosine is 5/7 is 2 root 6 over 5. Questions for me about that? And I know it takes a little practice. I know it seems a little bit weird. It's okay if you're not quite comfortable with it yet. But ask me those little questions. We'll try to fill in the blanks for you and help us understand that. Okay, let's try another one. Okay, is there a question? Good, good, good. David, question?
It's not really a question. It's just I actually have a dentist appointment.
Okay.
I forget that I had it, but I will have to leave like this meeting right now.
No problem. So you're supposed to notify the attendance office so you can shoot them an email that you had to leave or when you get back or whatever. And the answer key is already posted. So we're just going to run through 2 more of those together and do some mixed practice. But the answer key in the Schoology folder has my work for all of those. So just go through that. And if you have any questions, let me know. Okay. I hope the appointment is a good one. They can go either way. Okay, so now we want to find the cosine of arcsine of -4/7. We want the cosine of the angle whose sine is -4/7. Okay, so remember, this on the inside, the angle whose sine is -4/7, arcsine is just talking about an angle theta. And we don't actually have to find that angle to find its cosine. We can still find its cosine. We want cosine of arcsine of -4/7. Is -4/7 a sine value you recognize from the unit circle? No, for sure not, okay? Everything was 1/2, √3/2s, and √2/2s. So what are we gonna do? We're gonna draw a triangle. Now the question is, where are we gonna draw that triangle? We're doing arcsine of -4/7. Where do the angles come from when sine is negative? When we're doing arcsine or sine inverse of a negative, where do our angles come from? What's the range for our angles there? And anybody can answer. Okay, 1 and 4, but specifically, Nicholas, when they're negative, which one is it? Is it 1 or 4 when they're negative? That's right. So we're down here in quadrant 4, which he's right to call it quadrant 4. Ms. Weaver still likes to call it quadrant -1 to remind me that those are the negative angles. So I'm going to draw my radius coming out from the origin, drop an altitude perpendicular to the x-axis, and that's where my little angle theta is going to come from. It's going to be that negative angle there in that quadrant. Okay, now, Nicholas, I'm going to go ahead and pick on you to help me finish this problem. So sine is what in terms of x, y, and r? Sine is what over what? Y over r. So next to that sine value, I'm going to write the y over r to remind me. That means my y value is 4, and my r value is 7. And because there's that negative out front, one of those needs to have the negative. It can either go with the numerator or the denominator. Which one should it go with, Nicholas? Which one should it go with? Y. It does go with the y. You're right. That's going to be -4 there. Why did you pick the y value? How did you know that? And there's a couple different reasons that are valid here. How did you decide on the y, Nicholas?
I think 4 is negative in the fourth quadrant right there. It's the y
Right.
value negative, sorry.
Right. So when you have your triangle drawn in the correct quadrant, you automatically can see that that y value should be negative. So yes, I agree. That's a perfect way to tell. The other thing to remember is that the radius is always positive. Remember, no matter what quadrant we're in, radius is always positive. So we knew that the y had to get the negative. But I like that too, that when you draw it in the correct quadrant, you'll see if it should be positive or negative. Okay, so there we go. We figured out which one it is. If we know two sides of a right triangle, we can find the third side with Pythagorean. You got it. So Nicholas, can you talk me through that? What's that going to look like?
X squared equals 7 squared plus -4 squared.
Okay, so be careful. Remember that we always want the hypotenuse by itself. So Pythagorean theorem says a squared plus b squared equals c squared, where c is always the hypotenuse across from the right angle. The other two that meet to form the right angle, those are the legs. Those are your a and b. So we would say x squared plus -4 squared equals 7 squared. Okay, and then can you talk me through solving that, Nicholas?
Yeah, -4 multiplied by itself would just be 16.
Uh-huh.
And then 7 squared is 49.
Okay.
And then subtract subtract 16 from 49.
Okay, and so that's going to give us
33.
okay. And how do
then
you do that
square
square?
that.
Okay, square root, which picks up the plus or minus option. Now, we're in quadrant 4, but we're solving for x. So is x positive or negative here?
Positive.
Okay, so I'm going to throw out the negative option. If our triangle were in quadrant 2 and we were solving for x, x would be negative. Okay, now I put a note to myself that in our examples next year for me to add some where we are solving, because our y is negative here, but it's not the one we're solving for. Okay, so I put a note to put some more examples in next year where we're solving for the one that's negative so that you remember. I just don't want you to think that it's always the positive one, because it's not. It totally depends on what quadrant you're in and which one you're solving for. So you're right. We're going to do square root of 33 here, positive. Remember, 33 is just 3 times 11, so those are both prime and no pairs. So it's just going to stay positive square root of 33. Okay, we now have all 3 sides of the triangle, so we can find any of the 6 trig functions that they want. Which one do they want? They want the cosine of the angle whose sine is -4/7. So what is cosine going to look like, Nicholas?
X over R, so just be square root of 33 over 7.
Beautiful. Excelente. Very nicely done, sir. Okay, now Nicholas was really confident on that and walked right through it. If you're not as confident and you have questions, you are still 100% normal, okay? So do not feel like, oh my word, he just knew what he was doing. That doesn't mean that there's anything wrong with you not knowing what you're doing yet, okay? So don't be discouraged about that. So that's one of the reasons I like to call on random people, is to kind of make sure we see that we work at different speeds and you're okay wherever you're at. Questions for me on this one before we try one more? Okay, let's try one more of these. Okay, we want cotangent of the angle whose cosine is 3 over 4. Is cosine of 3 over 4, do we see a cosine of 3 over 4 on the unit circle anywhere? No, so what are we gonna do, Sanjita? We're gonna
first make a triangle on
yes,
the
we
graph.
can draw a triangle. Where will we draw it? Where will we draw it?
So we
our
draw in first quadrant.
excellent. Because it's positive, and so we're in quadrant 1 where everything's positive. Okay, so Sanjita, what can you tell me about cosine in terms of x, y, and r? What is cosine in terms of x, y, and r?
Cosine is x over r.
Okay, so if I write that label, x over r, right next to the cosine value, that reminds me that my x value is 3 and my r value is 4. Okay, so if we know two sides of a right triangle, we can always find the third side with,
Pythagorean theorem.
okay, so what will that look like?
It would be 4 squared equal to 3 squared plus x squared, you could say.
Okay, and because we already have an x, I'm going to call it y, just so we don't confuse ourselves about which is which. So I'm going to call it y. Now, Sanjita's rocking this. She's also going really fast through this. So let me slow down a second for anybody who has questions. I also want to point out that in y'all's pear deck responses, not everyone is making that a right triangle. So to emphasize that when you draw that, you have the radius that is the terminal side of the angle coming out from the origin. So that's our angle theta right there in standard position. From that radius, you drop an altitude perpendicular to the x-axis, and that creates the triangle we use to find our trig values. So that altitude that you drop is perpendicular to the x-axis. Make sure that you mark that as a right triangle. If it weren't a right triangle, we wouldn't be able to use Pythagorean theorem or any of those other things. You've got to show me why you know we're legal to use Pythagorean theorem. Okay, Sanjita, can you take it from there? You're doing great. Can you help me solve this Pythagorean theorem?
Yeah, so 4 to the power 2 equals 16.
Okay.
And 3 to the power 2 equals 9. And then we have y squared.
Mm-hmm.
Then we subtract 9 from both sides.
Mm-hmm.
And then we square root 7 on square root 2 on both sides.
Mm-hmm. Okay, and that picks up the plus or minus option. Which one do we want here? Positive or negative square root of 7?
Positive.
Right, because in quadrant 1, everything's positive. Okay, you can see it's going up. All right, we now have all 3 sides of the triangle. We can find any of the 6 trig values they want. They want cotangent, so how are you going to find it, Sanjita?
Cotangent is x over y.
Okay.
So we're going to plug it in from the triangle.
Mm-hmm.
So it would be 3 over the square root of 7.
Are we finished?
I think so.
Okay, so we were finished every other time, okay? The only reason we're not finished on this one is because we've got a radical in the denominator. So can you help? Mm-hmm.
Yeah, so what we're going to do is we're going to multiply square root of 7 to both sides.
To both the numerator and denominator? Uh-huh.
Yes, and it would equal to 3 times the square root of 7 over 7.
Beautiful, 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 beautiful. Okay, I love it when the people I call on totally know what they're doing, but I worry that the people that are still struggling are going to feel intimidated by someone going so smoothly through it. So do I have questions from anybody? And even my kids who really get it, sometimes that's where I get some of my best questions, because you are trying to put this stuff together and thinking. So just know that I want to hear from anybody, whatever your questions or thoughts are. Answering questions makes me happy. Uh-huh.
Can you explain how you know which part's the radius and which part goes in which? Like when you're drawing
Sure.
a triangle?
Yeah, for sure. So that's why we reviewed what the 6 trig functions are in terms of x, y, and r at the beginning of this lesson. This told us it is the angle whose cosine, it's the angle whose cosine is 3/4. So we know its cosine value, okay? We know that the cosine of this angle is 3/4, okay? It's the angle whose cosine is 3/4. So we know its cosine is 3/4, and we know cosine is x/r, which means x equals 3 and r equals 4, okay? And so that's how we know to plug the x value in as 3 and the r value in as 4. So we look at the trig function that they give us on the inside, okay? We were looking at the angle whose cosine was 3/4, so we knew the cosine was 3/4. That's why I wrote the fraction with the labels in terms of x, y, and r right next to it, so I would be able to pull out the correct values in the correct position in the triangle. Okay, any other questions for me there? I think one of the biggest things is knowing which quadrant to draw your triangle in. And so you're just going to think about your little acrostics that we have to help us remember. Cosine, which means cosine and its reciprocal secant, sine and its reciprocal cosecant. We'll go to those 2 quadrants. And then cotangent. Okay, we'll go to those 2 quadrants. So you're just looking at whether it's positive or negative, and then drawing it in the correct quadrant for that inverse function, okay? Okay, so that's what I have for the new material. That's what I have for new material. If it's not from the unit circle, you draw a triangle and you solve it, okay? I did put together some mixed practice. Sorry, making sure I was on the right slide. I put together a couple of slides of mixed practice with everything from this unit so that we can just practice a little bit of everything because like I said, your assignment today is the study guide over everything. And when you finish that, you're going to be doing the test. Okay, so this is stuff we've technically done before, so I'm going to call on you guys to help me with it, okay? No problems if you're stuck or not sure how to do something, we'll help you. Okay, but let's go ahead and run through some of these. So everybody should have their unit circle up, or, oh, I forgot to show you guys. Oh, no, I did. I think I did. That was the other day. The inverse unit circle, if you like it, and the regular unit circle will need both a little bit, okay? And let's go ahead and get started and try some of these. Okay, so can you help me with this first one? Did you have a question, Nicholas? Be right back. Okay, sorry, I just saw it. Okay. Let's see. I wish I could remember who I've called on sometimes. Imad, can you help me with this first one? We're looking for the angle whose cosine is -1/2. The angle whose cosine is -1/2. What do you see? What are you thinking, Imad? Can you help me with that? The angle whose cosine is -1/2. Cosine inverse of -1/2. What do you see? What are you thinking, Imad? And you can unmute and tell me or type it in the chat. And if you're not sure, that's okay too. I'm glad you can do it, Amir, and I may have you help me in just a second. Last call for Imad. Are you with us, Imad? Are you here and working? Otherwise, I just need to change your attendance. Okay, so let me change his attendance. And Amir, sure, I will let you help us with that one. Let me go. Okay, talk us through it, Amir. What are you going to do? What do you see? What do you think then?
So when I saw the -1/2, so then I started looking in quadrant 2 and 4. And when I did the line thing,
you said quadrant 2 and 4. You said quadrant 2 and 4. It is not quadrant 2 and 4. Cosine inverse only goes to quadrant 1 or 2.
wow.
Okay, so remember, it's restricted. We had to restrict it so that it would pass the horizontal line test, so that its inverse would be a function, and we would all give the same one correct answer. Okay, so for cosine inverse, it's only either quadrants 1 and 2. In quadrant 1, cosine is positive because it's the x coordinate. In quadrant 2, cosine is negative because it's the x coordinate. So we are definitely in quadrant 2.
Then when I looked in quadrant 2, I found it was 2 pi over 3.
Okay, and because you were looking for the x coordinate, right?
Mhm. Yeah.
Okay, I agree with you. That's right there at 2 pi over 3. Okay, if you guys have questions, just unmute and tell us. Otherwise, we're just going to keep rolling forward here, but I totally want your questions, okay? Let's see. Ananya, can you help me with this next one? We want the angle whose sine is 0. We want the angle whose sine is 0.
If the sine is 0, would it be 1?
So an angle of 1 is what you're saying?
Yeah.
So where is an angle of 1?
But there's no angle. Wait. Sorry, I confused myself. So
No, that's okay. And that's why I said, because we're switching back and forth, it's easy to confuse ourselves. So if we slow down and think about that, okay, where are we looking for sine inverse? Where are we looking?
sine inverse is quadrant 1.
Or quadrant -1. But because this is not negative, we're not going to need quadrant -1. We're going to be somewhere in quadrant 1. Okay. So where in quadrant 1 do we see a sine value of 0? Is sine my x or my y value?
Sine is your y value.
That's right. Sine is my y value. So where do I see a y value of 0 in first quadrant?
It's at 0 degrees.
Excellent. Okay, 0 degrees, or I'm going to call it 0 radians, both because it's easier to write because I don't have to write a degree sign, and because radians are our default, and I really want you guys getting comfortable with radians. Okay, so good job. Very nice, man. Okay, that next one's a little bit harder. Tan inverse of 1. Okay, tan inverse of -1, rather. Okay, tan inverse of -1. And it's just a little bit harder because tangent and cotangent, we have to do a little bit of work to find them. So let me just talk you through this as a reminder real quickly. So we know tangent is y over x. So if it's going to simplify to 1, x and y must be equal to each other. They must be the same, but one of them is negative. One of them is negative. That's why it's negative. Okay. So if we're tan inverse is negative, if the angle whose tangent is -1, what quadrants are we looking in for tan inverse if it's negative? Can you help me finish this one? Megan, what quadrants are we in if tan inverse is negative?
Sorry, 1 second.
That's okay. And I'm writing it up still too. I needed a second. Okay. So what quadrants are we in if tan inverse is negative?
It would be 1 and 4, right?
1 and 4, or Miss Weaver likes to call it -1, but you're right, it's quadrant 4. Okay, and so which of those two are we in when it's negative?
4.
Right, because everything's positive in quadrant 1. So we now know we're zooming in on quadrant 4. Okay, so where down here in quadrant 4 are my x and y values the same, but one of them's negative? Where are my x and y values the same, but one of them's negative?
-40, -45 degrees.
Okay, but you said it in degrees, and our default is radians, so I'm going to call it
The negative pi over 4 then.
excellent, -pi/4. Very nice. Okay, so remember, that's one of the reasons we love a denominator of 4, because both coordinates are √2/2 and √2/2, and we don't have to stress about which one is which. Because it's quadrant 4, my x is positive and my y is negative. And so if we did that to double check ourselves, if we're looking for the angle whose tangent is -1, if we do tangent of -pi/4, we said that's y over x. And our y value is -√2/2 there. And our x value is √2/2. And you can see that does in fact simplify to -1. Okay, so the angle whose tangent is -1 is -pi/4. And you didn't have to do that to check it. I was just showing you guys how it did check, and that was true. Okay, very nice, Megan, good job. So far you guys are doing well. Okay, let's go ahead and try a few more problems. I think I have 3 review slides for us. Okay, so on this slide, that first slide was kind of a little more straightforward, a little more basic. On this slide, we're picking up the reciprocal trig functions. So this first one is a secant inverse. And then we've got some compositions. Okay, so let's give these a try. Let's see how we do. Okay. So that first one is the angle whose secant is positive root 2. The angle whose secant is positive root 2. And let me call on somebody. Shay, can you help me with this one?
Yeah.
Okay.
So for secant, what isn't that the reciprocal of sorry, it's hard for me to remember the X and Y's and R's, like the
That's okay. So remember that every S needs a C. So its reciprocal is the one that's going to start with a C of our basic trig functions.
so it's
That's
cosine.
Yes, that's right. So it is. You're right. It's the reciprocal of cosine. So what are we going to do with that secant value?
Wouldn't it be can I have a little help, please?
Sure, for sure. So you're right that we do not have our secant values memorized. And so because we don't have our secant values memorized, we want to use the reciprocal function. So we want to use cosine inverse instead of secant inverse. We know that those are reciprocals, so it's just going to be the flip of the fraction of that. So if I turn that secant value into a fraction by putting it over 1, then its cosine value should be the flip of that. It should be 1 over root 2. Now, it'll help you here if you rationalize the denominator. So let's rationalize that denominator. Let's go ahead and multiply that by root 2 over root 2.
So square root of 2 over 2.
Beautiful. And that's the reciprocal of that fraction, square root of 2 over 2.
Which that would be, it would be pi over 4.
Okay, and tell me how you knew that. You're right. That's exactly
I knew that because cosine is either the first quadrant or the second quadrant. And
Uh-huh.
since square root of 2 over 2 is positive,
Mhm.
it aligns with pi over 4.
Excellent. So we were in quadrant 1 where everything's positive, and cosine is the x value, and we found that x value of square root of 2 over 2 at pi over 4. That was exactly right. So you can put that answer here or here. Okay. It is the angle. So the angle whose secant is root 2 over 1 is pi over 4. Okay, very nice, Shay. Good job. Okay, so let's try that next one. It's tan inverse of root 3 over 3. The angle whose tangent is root 3 over 3. The angle whose tangent is root 3 over 3. Glad you're back, Nicholas. Thanks for letting me know. Let's see. I'm going to talk you through this one just because this is one where I kind of suggested 2 different ways to approach it. So let me give you those 2 options, and then I'll pick one of you to pick one of those options. Okay, so we're looking for the angle whose tangent is root 3 over 3. If you're like Miss Weaver, you haven't memorized your tangents, but you know that tangent is y over x. Okay, so tangent is y over x. So we're looking for the angle whose tangent is root 3 over 3. Well, it's positive, so I know that we're in quadrant 1 where everything's positive. Okay, and if I look in quadrant 1, I know that my tangent has to have a root 3 in it. So where do we see root 3s in quadrant 1? We see one in the x coordinate at pi over 6, and we see one in the y coordinate of pi over 3. So our answer either has to be pi over 6 or pi over 3. And we're not sure which one has that tangent because we don't have our tangents memorized. So I'm going to take the tangent of pi over 6, and I'm going to take the tangent of pi over 3, and I'm going to see which one is the angle whose tangent is root 3 over 3. Okay, we got a 50-50 shot of getting it. It's got to be one of those 2 because the only place we see square root of 3 in first quadrant is at those 2 angles, so it's got to be one of those 2 angles. So just try the tangent of those 2 angles and see which one it is. Okay, so if we try pi over 6, tangent we know is y over x, so my y value there is 1/2, and my x value is root 3 over 2. When my denominators are the same, they cancel, and so that's 1 over root 3. When we rationalize it, multiply it by root 3 over root 3, we get root 3 over 3. Is that the tangent we're looking for? Yes, it is, which means that's the angle we're looking for. That's the angle we're looking for, pi over 6, okay? The angle whose tangent is root 3 over 3 is pi over 6. Okay, so I got carried away there and I finished that one myself instead of letting you guys pick. Okay, so that was one way to do it. Just look at the two angles that it could be, the two angles that have a root 3 somewhere in them, and try those two and see which one it was. We got lucky. It was the first angle we checked. It was either going to be that one or the other one. So you're not going to have to do much more work if it's not the first one. It'll be the other one, okay? But the other way to do that is the way Miss Weaver likes to do it, but I've had more practice, so I feel more comfortable with it. So it's okay if you're not ready to do it this way yet, but I know some of you are. I know some of you are. Okay, the way I like to do it is I like to decompose that tangent value. I like to decompose that tangent value. I know tangent is y over x. And I know because I've rationalized a lot of fractions, I know that root 3 over 3 came from a 1 over root 3 that they rationalized. Okay, when I see that root 3 over 3, I'm like, oh, that was just 1 over root 3 before they rationalized it. And I know that those both had a denominator of 2. They just canceled them because they were the same. So I'm looking for the angle whose y value is 1/2 and whose x value is root 3 over 2. And where does that happen? It happens at pi over 6. It happens at pi over 6. So you can deconstruct the tangent value, or you can just check the tangent of the two angles in that quadrant that have a root 3 in it. Both ways will give you the same correct answer. Questions for me about that with the tangent and cotangent?
Yeah, I have one.
Uh-huh.
Sorry, I'm still confused on how you got the tan pi over 6 and the tan pi over 3.
Okay, so I was looking for the angle whose tangent was root 3 over 3, and it was positive, so I knew I was in quadrant 1, okay? So where in quadrant 1 can we find values that have root 3s in them? We want one that's going to have a tangent of root 3. So where do you, root 3 over 3. So where do you even see a root 3 in quadrant 1?
Oh, pi over 3 and pi over 6. Okay, I get it.
Yes. So that's how we're doing it. We're more just like we understand the idea of what we're doing, that we're looking for the angle whose tangent is that value. So we're like, okay, well, where could we even get a tangent of that value? It's got to have a square root of 3 in it somewhere. And when I'm looking in that correct quadrant, and we know quadrant 1 is the correct quadrant because our tangent's positive, and tan inverse when it's positive goes to quadrant 1. So we're like, where in that quadrant could it even be? And there's only 2 that it has a chance of being. Okay, and so we can just try those 2 and see which one it is. Or we can decompose the tangent and we'll figure it out that way. Okay, other questions on that? No problem. Other questions? Okay, so now we're going to do a composition. We did a few of these the other day, so I'm going to let one of you guys kind of try helping us with that one. Taryn, can you help me with this composition? Sine inverse of cosine of pi over 3, the angle whose sine is the cosine of pi over 3. The angle whose sine is the cosine of pi over 3. Do you need some help thinking where to start?
Yes.
All right. So with composition of functions, when they're on the unit circle, the ones we did earlier today were not on the unit circle, so we drew a triangle for those. But this is on the unit circle. So we're going to start on the inside and we're going to work our way out. So I'll copy that first step, sine inverse, and I'm going to just leave that blank for right now. I'm going to start on the inside and try to find the cosine of pi over 3. So Taryn, what's the cosine at pi over 3?
60 degrees.
Pi over 3 is 60 degrees. What's the cosine there?
Oh, sorry, the cosine. It's 1/2.
Yes, it's the x coordinate because cosine is 1/2, so you're right. It's 1/2, okay? Now that we took care of the inside, now we're ready to do the outside. So now we want the angle whose sine is positive 1/2. The angle whose sine is positive 1/2. So can you talk me through finding that? What is the angle sine is positive 1/2?
That'd be 30 degrees.
And can you tell me how you knew? Can you talk me through your reasoning?
It's I looked at
I'll help you a little bit because sometimes we just see it and we just know and we have trouble putting it in words, okay? So if you want to practice speaking math. That's one of the things we want to learn to do, but I can help you a little bit with those words. Okay, so you were looking at quadrant 1 because your sign was positive, okay? Remember, we know, oops, if I can get a pen. All of the trig functions, when they're positive, they're coming from quadrant 1. So it doesn't even matter which trig function. If it's positive, we're looking in quadrant 1. So we're in quadrant 1. Sine is the y value. So if we're looking for the angle whose y value is 1/2 in quadrant 1, that happened right there at, you said 30 degrees, but guys, you need to remember now that we're grown-up mathematicians, radians is the default for angles. And so like when you want to start by just getting used to those radian angles. And so that's pi over 6. It is equivalent to 30 degrees. That was correct. But we want to get, a lot of times on your test, I think it'll make you give it in both degrees and radians. So just whatever the instructions say there. Okay, good job, Taryn. All right, any questions on that? So the composition, not too bad, but it's double the work because it's 2 problems in 1. We start on the inside and work our way out. Okay, and then I think, let's take a look. My last mixed practice slide. Now, this is the last one I'm going to make you do together, but I do have another slide of more mixed practice if you feel like you need more help. Okay, so this last one that we're going to do together is another composition. Okay, it's got some reciprocal trig functions in there, reciprocal inverses. Okay, so it's just a good, nice, hard problem to work on. Okay, so let's give it a try. Let's see what we see and what we're thinking. Okay, and let me get one of you guys to help me with that. Valerie, can you help me with this one? Where would you start with this problem? What do you see? What are you thinking? We want sine of the angle whose cotangent is -√3. We want the sine of the angle whose cotangent is -√3. Still confused? No problem. I'm going to help you a little bit, but I'm still going to ask you some questions, Valerie. Okay, it's a composition of functions. It does look like it comes from the unit circle because it's got a √3 on there, which we see those on the unit circle. So with compositions of functions, we're going to start on the inside and work our way out. So right now, I'm going to leave the sign on the outside for now, and I'm going to start on the inside by looking for the angle whose cotangent is -√3. I want to find the angle whose cotangent is -√3. Okay, remember, we said cotangent and tangent take a little bit of work. If I'm thinking about what quadrants we're in, what quadrant are we looking in, Valerie, for the angle whose cotangent is -√3? I noticed
quadrant 2.
Yes, very nice, because it's negative, okay? So we're looking in quadrant 2. And I see its cotangent is -√3. So which way do you like to do these, Valerie? Do you like to decompose the fraction, or do you like to just try the 2 angles that it might be?
Decompose the fraction.
Okay, I like that way too. It takes a little practice. I recommend if you're trying to decompose the fraction, just slow down and you can figure it out, okay? So cotangent is what over what in terms of x, y, and r, Valerie? Cotangent is
x over y?
Yes, it's x over y. Okay, so if we're trying to decompose this fraction, this -√3, to be a fraction, that had to be -√3 over what?
1.
Right, over 1. So right away, I know that that came from a -√3 over 1. And what do we know about those 2 denominators?
They cancel out.
Yeah, they did cancel out, but before they canceled out, they were both 2's, right? They were both 2's and they just canceled. Now, make sure that we have that negative in the right place. We're in quadrant 2. It is the x that's negative and the y that's positive, so that's okay that I had the negative in the numerator. Otherwise, I would put it in the denominator if it was in quadrant -1 or 4. Okay, so we're looking for the angle in quadrant 2, where my x value is -√3 over 2 and my y value is 1/2. Where is that, Valerie?
That is at 5 pi over 6.
It is. It's right here at 5 pi over 6. Okay, right here at 5 pi over 6.
How did you know that the 2 went underneath the square root of 3?
So I knew that this was on the unit circle, okay? So I'm thinking about what we know about our trig values on the unit circle. And anywhere where it's 1, √2, √3, like that, The denominators are all 2. Look at your denominators on the whole unit circle. They're 2 on everything except for the quadrantal angles. And the quadrantal angles are 0 and 1. So since this wasn't a 0 or 1 for the cotangent or an undefined or a 1, yeah, an undefined or a 0, then I knew it was one of those other angles, and they all have denominators of 2.
Oh, okay.
You even said that the denominators were the same. You knew they were the same and they canceled. So on the unit circle, we know it's always 2 if it's from the unit circle. And then
Yeah, thank you.
no problem. So you said that angle is 5 pi over 6, and I agree. And that's the first half of this problem. So we took care of that part. We found the angle whose cotangent was -√3. And remember I said the composition problems, they're double the problems because it's 2 problems in 1. We did the inside one, now we need to do the outside one. We want the sine of 5 pi over 6. So what is the sine of 5 pi over 6, Valerie?
Is it 5 pi over 3? Or I'm not sure.
Okay, we're not looking for an angle. This isn't sine inverse.
Oh.
This is sine. We
It's
want the
1/2.
Very nice. We want the sine, which is the y value, and you're right, that's 1/2. The sine of the angle whose cotangent is -√3 is 1/2, okay? The sine of the angle whose cotangent is -√3 is 1/2, okay? Questions about that one? And good job. You did a good job walking through that, Valerie. So,
Thank you.
Taryn, did you have a question? I see you're unmuted.
No, sorry, I just left it there because I wasn't paying
Yeah, from helping earlier. No problem. I was just making sure. Other questions on that one? Okay, so if you're feeling confident, then I feel good about letting you go work on your study guide. When you get your study guide done, you can start your test if you want. If you don't get your test finished before you leave for spring break on Friday, make sure when you get that remind from me on Monday or set your own alarm on your calendar for Monday that you use your asynchronous Monday to refresh and do your test, okay? The test is due just before midnight on our asynchronous Monday, okay? I do have one more slide of practice slides, practice problems, mixed practice, if you'd like a little more practice. Okay, so I do have some extra practice here if anybody wants to stay and do a little bit more together. You can do it over spring break, Noah, but we want you to take a break from school over spring break, okay? For your mental health and for your sanity and all that good stuff, I want you to let yourself take your hair down and have some time to relax. So my suggestion is either get it done before spring break or use that asynchronous Monday when you're back to do it. But it will be open that whole time. It won't be closed, okay? I can post the video, Nicholas. I'll go put a note to myself right now so that I remember to post the video. In general, we don't post them because we already have videos made that teach the content. And so watching the whole class discussion can be a little monotonous. But if you request it and you want it, I'm happy to post it. FYI, when we get back from spring break, I'm going to be out 2 days that week. I'll still get my grades done and all that good stuff, but you'll notice on our Schoology folder for that day, you're going to have another teacher's link to go to for that Tuesday that we're back, okay? All right, so I still have a lot of people in that meet. You too, Sarah. Bye, Jay. Is that because we do have people that want to do some more practice together? Just yay or nay? Yes. Okay, then let's do it. Let's do it. Okay, so this first one we're doing is cosecant of the angle whose cosine is -√2/2. Cosecant of the angle whose cosine is -√2/2. So Taryn, like by triangle questions, oh, you mean ones that are not on the unit circle? I can for sure make another one of those up. I think I might have one on here. And if not, I'll make one up in just 1 second. So let's see. Noah, do you care what kind of problems we do? Do you want to do all of them? If I send you to...
Anything's fine, really.
Okay, so then let's take Taryn's request first for one that's not on the unit circle, and then we can come back and do this practice slide that I have here. Okay, so I'm going to just make one up real quickly. So let's try, we can do any of the 6 trig functions once we know it. So let's do that we want to find cosecant of the angle whose sine is, now I'm just making these numbers up, so they may end up being a little ugly, but we'll be fine, we can handle it. I'll say it's gonna be y over r, so my r needs to be bigger. So let's do, let's say 3/5. Okay, this one actually won't be too bad. Let's do 3/5. Okay, so we would like cosecant of the, oh, let's not do cosecant and sine because cosecant and sine are reciprocals. That's one of those which, okay, so let's do this two different ways. Let's do cosecant of the angle whose sine is 3/5, and then let's do cosecant of the angle whose cosine is 3/5. Okay, and so we'll talk real quickly about why I wanted to do both. Okay, so first of all, that first one that I wrote, cosecant of the angle whose sine is 3/5, that's one of those that we can do by working smarter, not harder. What do we know about cosecant and sine? Cosecant and sine are reciprocals. That's right. They're reciprocals of each other. So the cosecant of the angle is, we just go find the sine value and we flip it. So if we already know the sine value is 3/5, how can we find its cosecant? We can just flip it. So the cosecant of the angle whose sine is 3/5 is 5/3. Okay. And so that's where we can use logic to do that one super fast, because those were reciprocal trig functions, okay? Now, let's go ahead and do the other one that'll be a little bit more work. Let's do cosecant of the angle whose cosine is 3/5. Let's do cosecant of the angle whose cosine is 3/5. Now, 3/5 is not an x value from the unit circle, so we've got to draw a triangle, okay? Let's take this up a notch. Let's make it negative. Let's make it negative to take it up a notch, okay? So we want to draw a triangle. What quadrant should we draw it in if our cosine is negative? What quadrant should that be in if we're doing cosine inverse of negative 3/5? When cosine is negative, what quadrant does cosine inverse take us to? That's right, it takes us to quadrant 2. We think about our cosine. Cosine inverse takes us to quadrant 1 or 2. Because it's negative, it's taking us to quadrant 2. So I'm going to draw my triangle in quadrant 2. Draw up an altitude perpendicular to the x-axis. Okay, so we've got our cosine value. We know the cosine value is negative 3/5. What is cosine in terms of x, y, and r? Which two values do we have there if we know its cosine is negative 3/5? Cosine is what over what in terms of x, y, and r? That's right, it's x over r. So this cosine value is x over r, which means my x value is 3, and my r value is 5, and one of them is negative. So in quadrant 2, which one of those gets the negative, the x or the r? Yes, the x is the one that's negative in quadrant 2, because you can see it's going backwards, so the x is negative, okay? Now, if we know two sides of a triangle, we can find the third side with Pythagorean theorem. Or, why did I say this one wouldn't be so bad? Do you guys recognize it? This one is actually a Pythagorean triple. It's a Pythagorean triple. Do you know your triples? So, yeah, 3, 4, 5. And this is a 3, 4, 5. But you have to be careful on these. You've got to make sure that the radius is the largest of the two. So if that was a, like, say they had given us the cotangent and the y was the 5, and I just wrote that 5 in the wrong place. Because I was already thinking ahead of my thoughts, okay? So that's going to be a 3, 4, 5 triangle. If the y was the 5, then it would not be a 3, 4, 5 triangle, okay? Because the radius has to be the biggest, okay? Now, if you didn't recognize that as a Pythagorean triple, no problem. You would just do negative 3 squared plus y squared equals 5 squared. 9 plus y squared equals 25. Y squared equals 16. Undo a square with the square root. We pick up the plus or minus option. So y is plus or minus 4. Would we want the positive or the negative one in second quadrant for y? Right, y would be positive in quadrant 2, so we throw out the negative option there, so y would be 4. So we can get it even without recognizing the Pythagorean triples. We give you Pythagorean triples sometimes to speed you up, okay? But now that we have all 3 sides of the triangle, we can find any of the 6 trig functions they want. Which one do they want? We're looking for the cosecant of the angle whose cosine is -3/5. So we're looking for the cosecant of that angle. We never actually had to find that angle, okay? We never had to actually find the angle. We just want to find the cosecant of that angle. So tell me, in terms of x, y, and r, cosecant is what? Cosecant is what over what in terms of x, y, and r? It's the reciprocal of sine, and we know sine is y over r, so cosecant is r over y. That's right, okay? So cosecant is r over y. We know our r value is 5 and our y value is 4. So our cosecant of the angle whose cosine is -3/5 is 5/4.
I'm gonna do flex time now. So
Okay, that's good. No problem. Bye, Noah. Taryn, how are you feeling?
Better. It's starting to make sense.
Yeah, it just takes a little practice. And I would recommend watching the video notes again. Like after we've done a little practice, it'll kind of reinforce it and kind of help you a little bit more. Do you want to go ahead and do some of those regular practice problems, the extra practice I had?
Sure.
Okay, let's do some of those. And let's see. And Alex, if you want to get in on this, just let us know too. We're happy to let you answer questions and help, okay? And the reason I have you guys help me with all of it is because you've already watched me do a bunch, okay? And so it's helpful to let you kind of walk through it and let me see where you're getting stuck so I can get you unstuck, okay? So trying this first one, Taryn, we want cosecant of the angle whose cosine is -√2/2. Cosecant of the angle whose cosine is -√2/2. Okay, it is on a unit circle, so we're not drawing a triangle. Okay, so it is on the unit circle. It's a composition, so we're going to start on the inside and work our way out. Okay, so we're going to keep the cosecant outside for right now, and we're going to start by looking for the angle whose cosine is -√2/2. So can you help me find that angle? What is the angle whose cosine is -√2/2?
3 pi divided by 4.
Because we were in quadrant 2, because the cosine inverse goes to quadrant 2 when it's negative, and you said that that was at 3 pi/4. I agree, beautifully done. Okay, now we want the cosecant of 3 pi/4. We want the cosecant of 3 pi/4. So what will that be? How do we find cosecant?
It's the opposite of secant.
No. Okay, cosecant is the reciprocal of sine. Okay, so the reciprocal ones go with the 3 original ones. So our original are SOA, our sine, cosine, and tangent. So secant, cosecant, and cotangent pair up with either sine, cosine, or tangent. So cosecant is the reciprocal of sine. Okay, now the other thing is you said opposite. In math, the word opposite means negative. Okay, so it's not the opposite of it, it's the reciprocal of it. It's the flip of the fraction, the reciprocal of it. Okay, so cosecant is the reciprocal of sine. So we're going to go find the sine value and we're going to flip it. We're going to flip it. Okay, so instead of being √2/2, it's going to be 2/√2. Which we need to do what now, Taryn? Okay, are you with me on that? Where the
I don't know.
Okay, that's okay. So, but do you know where I got that? So cosecant we said is the reciprocal of sine.
Because isn't it the sine but opposite since it's cosecant? I mean reciprocal.
Yes, it is. So I went and grabbed the sine, which is the y value at that angle, and I flipped it. I did the reciprocal of it. Okay, the only reason we're not finished is because we still need to rationalize it. So can you talk me through that?
Yeah.
Or do you have another question first? Are you okay with where we're at, or do you have a question?
No, I'm fine.
Okay, if we rationalize that, what do we do? So rationalize just means to get rid of the radical in the denominator. So if there's a square root of 2 in the denominator, we're going to multiply by whatever's under the radical in the denominator. So if there's a root 2 under it, we're going to multiply it by root 2. What we do to the denominator, we have to do to the numerator. Okay, and when we multiply that, in the numerator, that's going to give us 2 root 2 because we multiply the numbers in front of the radical together, and then we multiply the numbers under the radical together. In the denominator, root 2 times root 2, we're squaring the square root, so it undoes the radical and just gives us 2, okay? It's the same as square root of 4, which is just 2, okay? That works as well. So final answer, the 2 over 2 will cancel, and we just get square root of 2. So the cosecant of the angle whose cosine is negative root 2 over 2 is root 2. Cosecant of the angle whose cosine is negative root 2 over 2 is root 2. Questions about that?
No.
Okay, it's just kind of building confidence, just getting a little bit of practice. Okay, let's try the next one. So the next one asks for a cosine inverse of cosine of negative pi over 3. Now I love this one. I think it's super fun. Okay, so let's look at it for just a second. Emily, if you wanted to look at this one, I just think it's fun to look at too. So cosine inverse of cosine of negative pi over 3. So we want the angle whose cosine is the cosine of negative pi over 3. Now this is where you might be tempted, okay, to say, well, cosine inverses just undo each other, so that's cosine inverse of cosine. So shouldn't it just cancel each other out? Shouldn't it just undo each other and be negative pi over 3? But the reason it won't be is because we have different restricted domains, okay? So we still want to walk ourselves through this problem. So let's still walk ourselves through it. Okay, so we'll leave the cosine inverse on the outside for right now, but let's try going and finding the cosine at negative pi over 3. Okay, so Taryn, what would my cosine, my x coordinate at negative pi over 3 be?
It'd be, sorry, it'd be at the 60-degree mark.
Okay, so it said negative pi over 3, so we're going backwards. So we're at negative 60 degrees or negative pi over 3. Okay, so we're down there, we're coterminal with 5 pi over 3. So what's my cosine, my x value? Negative pi over 3?
1/2.
Yeah, it is still 1/2. Okay. Now we want the angle whose cosine is positive 1/2. So what is the angle whose cosine is positive 1/2?
5 pi 6. I mean, 5 pi divided by 6.
So at 5 pi over 6, my sine is 1/2. Okay, I want my cosine to be 1/2. So we are in quadrant 1 because it's positive, okay? But where in quadrant 1 is my cosine 1/2?
Pi over 3.
Yep, at pi over 3. So the angle whose cosine is the cosine of negative pi over 3 is positive pi over 3. So I think that's interesting because if it weren't trig functions, inverses would straight undo each other and they would just cancel each other out. In fact, that's the way you test for inverses in regular functions. You do the composite. F inverse of f of x needs to equal x. It needs to get you back to the same input. But with trig inverses, because the restricted domains are different for the functions, when you have a negative, you can end up at a different angle. So I think that's interesting. Okay. Question about that, Taryn?
No.
Yeah, that was so interesting. But I thought you might like to see that it doesn't, you know? I think it's cool. Okay. You want to try one more?
Yes, please.
Okay, let's do it. We want secant of the angle whose cosecant is negative 5 over 2. We want secant of the angle whose cosecant is negative 5 over 2. Secant of the angle whose cosecant is negative 5 over 2. Is it on the unit circle, Taryn?
Sorry, you cut out for a second. Could you please repeat?
Yeah. Is it on the unit circle?
Oh, no.
So what are we going to do?
We have to make a triangle.
Okay. What quadrant should we put that triangle in?
In the fourth one.
Very nice. Because cosecant, just like sine inverse, goes to quadrant 4 or -1 when it's negative. So you're right. We're in that quadrant. Okay. What do we know about negative 5 over 2? What letters is that in terms of x, y, and r?
It's y and is it yr?
Sine is y over r, but this is the reciprocal. So
it's ry.
Yes, it's r over y. Okay. And so make sure that you go slow enough there that you get the right thing, or else you'll have them in the wrong place and it won't work out. Okay. One way that we could have checked ourselves there, if you put y over r, we know the radius has to be the largest. And so when you went to plug it in and the radius wasn't the biggest, that should have like clued you out into the fact that you probably had a little mistake. Okay, so we're plugging those in. We know our r value is 5 and our y value is 2. Which one gets the negative?
The y.
Yes, because radius is always positive, and because you can see in that quadrant that the y should be negative. Okay, now what?
We then use Pythagorean theorem to find the x, which is the third line.
Excellent, the third side. So what's that going to look like?
It'd be sorry.
So Pythagorean theorem says a squared plus b squared equals c squared. Okay, where c is always the hypotenuse, the one across from the right angle. Okay, so what would that look like in this triangle?
25. Negative. No. 4 minus 25, which is.
Okay, but you're like skipping steps. I always like to see the first step with no changes made. So I always want to see x squared plus negative 2 squared equals 5 squared. And after you show me that, I don't care how many steps you show, but I don't want you to skip steps before that. Okay? All right, so what's that going to be?
That'd be 25 minus 4. And then you'd square root them both.
And which picks up the plus or minus option. Do we want the positive or the negative option here?
We want the positive because it's in the fourth quadrant, so it can't be negative.
Right. So x is positive. You're right. And so 21 is just 3 times 7. So those are both prime and no pairs. So it's going to stay the positive square root of 21. Okay. Now what?
Then
okay, so we wanted the secant of the angle whose cosecant was negative 5 over 2. But we didn't have to actually find the angle. We can still find its secant now because we know all 3 sides of its triangle. So we can find any of the 6 trig functions they want. They want secant. So what is secant in terms of x, y, and r?
Secant is.
Secant is what you were going to say? Go ahead.
It's the reciprocal of the x value.
Right. So it's the reciprocal of cosine. Cosine is x over r. So secant will be
21.
Well, I just meant in terms of x, y, and r. It'll be r over x, okay? So we do think of cosine as just the x value, but that's when it's on the unit circle. It's always x over r because on the unit circle, the radius is just 1, so we think of it as just x. But you want to write it here because we're not on the unit circle. You want to write it as, think of it as x over r, so when you do the reciprocal, it's r over x, okay? And so what would that be?
That'd be sorry, it'd be 5 over square root of 21.
Which, when we rationalize that, what will that be?
You have to multiply them both by square root of 21, and then you get square root 21 over 21, I think.
Beautiful. That's exactly right. Very nice. Okay. And that's all the practice problems I had pre-written up. Do you need to practice anything else in particular?